last lesson, I taught you exercise 2E, and I revised through your matrices, but then I got into inverse matrix, and that's where everything you need to understand comes from, right? So I'm going to quickly revise it, and then I'll apply it in exercise 2F. We're applying what we understand, and that's all you're really doing. Exercise 2F and 2G is likely to be on the exam. If they were to assess you, that's all they're looking for. They're not assessing if you can add matrices. They don't care if you can multiply matrices. What they're more interested in is, do you know how to solve a problem? Can you apply those skills? Because when you apply them, you are going to multiply, you're going to add, you're going to subtract matrices, you're going to do the inverse. So all of that is basic. But what you need is 2F and 2G, right? So let's recap. What does it mean when we talk about the determinant of A being 0? What does that mean? Can I please have, yes, Aaron, what does it mean? Say it again, there is no, okay, so what does it mean when you say you're right? When the determinant is equal to 0, yes, it is true that you do not have an inverse. An inverse is undefined. But what does that mean when you have an undefined inverse, or the inverse of matrix A does not exist? What does that imply? What does it imply? Yes, Basil? There's no intercept. Because remember, when you're finding the inverse, it allows you to solve for a matrix of coordinates. And that coordinate really means just the intersection of two straight lines. If you can't find an inverse, it means you can't find a coordinate. If you can't find a coordinate, it just basically means you have no intersection. But when do you not have an intersection of two lines? What possibilities, Athena? Yeah, exactly, because when we're talking about a point of intersection, when we're talking about one, we're not talking about many. So when they have parallel lines, they never intersect. So of course you're never going to find an x and a y coordinate. And same thing if you had this exact same line, you're never going to solve for an x coordinate and a y coordinate. There are infinitely many of them. So the example I gave in class was I said if I asked you to find y equals 3x and y equals 3x and I said solve for x and y, you can't. Because if you do substitution method and you let them both equal to 3x equals 3x, you end up with 0 equals 0. It doesn't mean anything. You can't solve for x and y. So when they're the same line, you can't solve for a coordinate. When they're parallel, so let's say y equals to 3x plus 1 and y equals 3x plus 2, those two are parallel. If you try to solve it, same thing again. You get 3x plus 1 equals to 3x plus 2, and you end up with 1 equals 2. You can't solve it again. So the only time you can't get a coordinate is when they're parallel lines or they're exactly the same lines. And that's what it means when the determinant is 0. Why is it that when the determinant is 0 that you said the inverse is undefined? How do we know that? Just in case you forget this definition, how do you know that? Why is it true that when the determinant equals to 0, you do not have an inverse? What was the reason again?
The determinant is like both is AD minus BC, I think.
Yep, it is AD minus.
Over that, so that's equal.
Fantastic. This is the formula which in the very last slide I showed you the proof for the inverse formula. So the inverse of a matrix, the formula was 1 over AD minus BC times, what was it again? What was it again? What was in the matrix, Ben? Good. D, switch the A and D's, and then that's a negative B, negative C. This is your formula, and we can already see that from the formula, 1 over AD minus BC. If AD minus BC ends up being 0, obviously you have an undefined answer. That's why they called this the determinant. Okay, they're just like, oh, well, I noticed that AD minus BC is it drives the whole entire thing whether you're going to get a coordinate or not. Does that make sense on where it's all coming from? Yeah? Okay, so I can now rub all that. So we've understood that. We understood when the A inverse exists. Actually, what does that mean? When the matrix A inverse does exist. So we just said when it doesn't exist, you have no intersection. If you have no intersections, the only possibility is when you have two parallel lines or exactly the same lines. That's when you can't solve for a coordinate. So what does it mean when you do have an inverse? What does that imply, Richie? There is an intersection. If there's an intersection, that means you can find an x coordinate and a y coordinate. So there's one point of intersection. We call that a unique solution. Okay, so we call that implies that you do have a unique solution. And lastly, what is an identity matrix? What is an identity matrix, Darja? Fantastic. It is your 1, 0, 0, 1. This is called your identity matrix. Why is it so important, Shirley? What's the importance of the identity matrix? Fantastic. Whenever you times that to any 2 by 2 matrix in this case, it will be the same. Just realize I put up the cord. Does that affect the... does! No!